In this video, I want to go over the review worksheet over vectors. Now, I already have this worksheet already worked out, so I just want to kind of talk through some of these problems to help kind of explain them. So the first one, determine the component vector for a force of 35 newtons in a direction of south 35 degrees east. So south 35 degrees east is this angle right down here. And remember, anytime you're trying to find your component vector, you always want the angle to go to the x-axis. Because now if the angle goes to the x-axis, my x-coordinate is just my distance, my magnitude, times cosine of that angle. And my y is just the distance, magnitude, times the sine of that angle. And that's going to give me my x and my y. Now, if I do that, both of them are positive because I'm just looking at the right triangle. But from understanding that this point here is in the fourth quadrant, that would be a positive x and a negative y. So my final answer is 20, negative 28. So that's taking a regular vector, direction and magnitude, and turning it into a component vector in terms of x and y. The other thing we have is to go back to our drawing, our parallelogram. And so we have a force pushing a box 10 newtons east, 20 degrees north. That is this side right here. And another force is pulling the box at 12 newtons at north 40 degrees west, which is this one right here. And once again, we always want to think about the angle to the x-axis. That kind of helps us when we start to have to do calculations. But in this case, all we're doing is just drawing. So we just draw our parallelogram, and then this blue line is, that blue vector is our resultant vector once we draw our parallelogram. Now, remember, one of the things you can kind of help as you draw these, if you want to try to draw more accurate, is at the end of any one of these vectors, you can think of there being a north-south kind of line. And so here is our 20 degrees again, and length 10, which will help us kind of figure out where to draw that. The next one, a force of 30 newtons is pushing a box 300 degrees. And remember, with 300 degrees, when we're doing directions like that, north is 0, south is 180, west is 270. So 30 degrees would be this angle here. And so here is our side of 30 with the angle of 30. Our other vector is 17 newtons, and it's west 20 degrees south, which is down here. And then we're looking for the resultant x. And if you remember, when you do these, you always want to find this angle here that is between the two sides. And the easiest way to do that is we look at this angle over here. This is 30, this is 20, and we know that those kind of corresponding angles of a parallelogram always add up to 180. So that if I ever have a parallelogram like this, okay, that's not a very good picture. Let me try again. If I have a parallelogram like this, and I know that this angle is 20, I know this angle has to be 160 because these two angles have to add up to 180. So I have a 30 and a 20, which makes this whole thing 50. So that means this angle here is 130. Or excuse me, 130. Once I know this angle is 130, I can then use the law of cosines up top here to find my x, and I get my x to be 42.949. Next, I want to find my angle. Now, this angle in here is theta, is this angle right here of the triangle. And if I find that angle is 32. but you'll notice that this whole angle here is 32, but this bottom part is 20. So if I subtract that 20, I get 12 degrees, which tells me that this angle here is 12 degrees north of west. And there's my two angles. Now, the next couple of problems we do with component vectors. So first, we have a ship with a course of 100 and a speed of 18. So if we look over here, course of 100 comes from due north, so that's 10 degrees past 90. 18 is the magnitude, and if we do our right triangle, we get our x and our y. Our current is going 4 degrees west, 15 degrees to the north over here. We find our x and our y, and then to find our resultant vector, all we do is add those. 17.723 plus negative 3.864 gives me 13, and negative 3.126 plus 1.035 gives me negative 2. And this is just in component form. Now, if we have something that's in component form, and we want to go back to our direction of magnitude, that's what the next question is. First off, if you think about our component form, this is our x, this is our y. And so our r, by Pythagorean theorem, is just r squared equals x squared plus y squared. So r is negative 5 squared plus 12 squared, which is 13. This is a 5, 12, 13 right triangle. Now, to find our angle, I like to do this with SOHCAHTOA. This is a right triangle. You could use law of sines or something. I like to just say inverse tangent is 12 over 5. I ignore the pluses and minuses. And I say, okay, here is my angle of the right triangle, which I know is this angle from west. So I have west 67 degrees to the north. Over here, my x is 8, my y is 6. So if I draw my triangle, first off, if I do x squared plus y squared equals r squared, I get r is 10. Then I do the same thing with tangent. And remember, anytime you're trying to find an angle here, what we're doing is we are doing inverse tangent. So if I want to find theta, I'm going to do inverse tangent of 12/5. Over here, theta is going to be inverse tangent of 6/8. Now, when I do these, I like to do everything with positive. I like to draw right triangles, and then I like to just think about positives and negatives based on what quadrant it is, instead of trying to deal with those as I draw the picture. The next one, a ship starts off traveling west 35 degrees south at 10 knots, and there's a current going north 10 degrees east at 3 knots. Find the resultant direction and speed of the ship, and we use any method possible. Now, I'm going to go through it here both ways. Here I've done it with components. Here I've done it by the drawing. So let's kind of talk about these both. Personally, now that we have gone over doing it with components, I feel it is much easier to do it with components than it is to do it with the drawing. The drawings can get very confusing. So the ship, west 35 degrees south 10, gives me these component vectors when I draw my right triangle. North 10 degrees 3. Once again, remember, when you find this, you have to use the angle to the x-axis, which is 80 degrees, to find my components. Now I can just add those together to get my resultant vector in component form. And once I have my resultant in component form, now basically I'm doing the same thing I just did up here in number 5, where I have the components, use Pythagorean theorem, use inverse tangent, and I can get my answer of 8.15 knots at a direction west 19.9 degrees south. Now if I draw the picture can be a little bit crazier. You can see here is my picture, my two vectors are, here is my vector of 3, here is my vector of 10, and I draw this picture, and I'm trying to find this. So what I have to do is I need to think about that, once again, drawing my north, south, east, west. Here is my 10, here's my 35. That means this angle in the middle is 45. Doing my law of cosines, I get the same answer, 8.159. Same thing I got up top. And now to try to solve for the angle, I got to draw my picture here, and I try to find this angle right here, theta, which is 15.069, but I know this whole angle here is 35, so the angle up here from west is 19.93. Now you'll notice these are off by a couple decimal places just because rounding as I'm doing all these problems, but they're close enough that we do the same way. So I don't really care which way you want to do that one. If you want to use components, that's the method I prefer, or if you want to try to draw the picture. Now for the last one, I think it's much, much easier using components. And this is one where they give you the result. So they give you the direction the airplane's going, and let me kind of start off by kind of drawing the picture. East 50 degrees north, 300. So they give us there. It ends up going 378 north 10 degrees, which is going to be to there. So what you have to figure out then is that is your resultant, that is your diagonal. You need to figure out that vector. And then you have to kind of reconstruct your parallelogram and try to solve it like that. I think that is much, much harder. If we use component vectors, we can figure out the component vector of the plane. We figure the component vector of the resultant. And then we can just figure out what does the wind have to be so that when I add the plane and the wind, I end up getting this. And then once you have your component vector, once again, you can convert it into direction and magnitude just like we did up in number 5. So there's kind of just talking through and explaining each of the problems on this review worksheet over vectors.